Hello, in this video I'll explain how to get the Taya Windows SDK and set it up properly in code so you can start making payments with Taya. So first you want to go to docs.taya.com in the Poslink and Windows section. Here you'll see a brief description of how the SDK works on Windows. For the purposes of this video, just know that the SDK is actually an executable. Your application should start as a subprocess. It will then talk to it via standard input and output JSON RPC messages, which we'll cover later. It then has a section to get the latest version of the SDK. You can use this link to download it. The zip file will contain a public certificate, which will cover more on the connecting to the SDK page, and it contains a distributable zip file with the executable and other important files. I already downloaded it, and this is the zip file. Here is the certificate, and for now I'm just gonna extract the actual executable folder. The next section shows an example of how to start the process once you have the path to the executable. You can see we're using C# here as an example, and we'll use that throughout the video as well. But you can also use any other language as long as it can start a subprocess and communicate with it via standard input and output. One thing that has worked really well for us is actually asking an LLM to convert a piece of code from C# to some other language. It usually does a pretty good job at that. After that, it shows some examples of JSON RPC messages. There's also a link here you can follow for the specification. But you can see here each method call will be the name of the method and send some parameters, and then there's a corresponding response which will say whatever it needs about the result of that call. And as you see here, you can use the standard input to write the JSON messages and the standard output to read the responses. Of course, we will cover next how to do that in a safer way. This is just here so you can see how easily it is to send message and receive. So before we proceed with connecting to the SDK section, I'd like to show you this Windows Forms C# app that I worked on, and we are going to use this app to show you how to integrate with our SDK. It's a very basic C# app. I can run it. And as you see, like, it just has some buttons to add some items to the cart, and then it has a configure SDK button and some transaction related buttons, for example, the payment and refunding the last transaction. So let's go to the connecting to the SDK section. So first step it talks about is verifying the SDK identity. Basically, it's important that your application is confident that it's talking to the real Taya SDK. How exactly you can do that? It depends on the guarantees of the hardware that you are using. For example, if it's not possible to install malware on it, then maybe you can skip this step. Otherwise, we recommend that you do it. And this is where the certificate comes in. You can use that certificate and check that the SDK executable is signed with the same private key. And this is a code in C# that you can use to check that the thumbprints match, like the certificate with the signature of the executable. So yeah, this is our recommended way of making sure that your app is always talking with a real SDK. So the next section is about starting the subprocess, and we can implement this on our sample app. I will start by copying this code over and creating a class here. Call it Taya SDK Manager, for example. And here I'll create a function, call it public void start process, and I'll paste this code. I will copy the code to the path to the executable and paste it here, doing the / thing to escape. And let's go back to the documentation. So next it shows complete example calling the match signature certificate that we talked previously. If you're gonna do this check, then this is a good place to do it. Besides this, it also creates this field in the class to hold the process instance, which is a good thing. We should also do that. Call it, so let's say it's a process. Let's call it process. And then here we'll do it like this. And let's go back to the documentation. So then it talks briefly about communicating with the SDK, shows some examples about the JSON RPC messages. Each message will be a single line. So when we see examples like this throughout the documentation, it's just so it's visually more friendly. But the actual message that is being sent should be one line. And the same thing for responses. It briefly touches on this way of implementing this communication. If you're using C# and maybe some other languages, we'll provide some libraries that make it so that it looks like you're calling like local methods and abstracts away the serialization and all those things from the implementation. You can definitely do that. For this video, I will do it manually, as I think even if you're using something like this, it just will give you some idea, some overview of how the things actually work. Given that there's a single pipe through which the responses come in, we should always be listening for those, because at any point we'll make some requests and you should already be listening to that. So to do that, in the start process, I'll also start this background thread here that is constantly checking for the standard output and trying to process the messages it receives. So once again, I'll copy this code here and I'll put it here, and I'll also copy the method and put it here. So the process response method would try to get the ID from the response and serve the result object to whoever is listening for it, which would be the methods that are making the requests. So ideally, like in this class, we would want to have one method in the SDK manager for each method of the SDK that the SDK exposes, but you have a single pipe listening for all the responses. So you need a way to link between the two things, and one way that you can use is to have this dictionary. Basically, let's copy paste it here while I explain. Basically, it's a dictionary of task completion sources. So it's something that waits the finishing of a task, let's call it, and it's those objects, and it will hold the actual response, which for this video we'll use, and for documentation we'll use JSON element, and those tasks are per request ID. So that you can, for each request that you're about to make, you wait for this task that with this given ID. I'll show you how to do that. So we can also copy this process response method. And as you can see, it gets the ID from the message. So again, we have this loop that's always getting the response. Whenever it gets any response, it calls this process response method, and here we're getting the ID from it. If it doesn't have an ID, it can be a notification. There's a section in the documentation that talks about it. For now, we'll just ignore those. This case is for unexpected situations. For example, if you send a malformed JSON. So there's also a section in documentation you can read more about it. Most of the times we will get a result instead of an error, and in that case we will complete this task completion source with this result. Let's go back to the documentation. So after this, we are set up to have like a generic function that sends one request, waits for the response, and returns that response back to the caller of this function. So let's copy that also. And let's go over it real quickly. So whenever you're calling this function, you'll send a method name and some parameters. optionally. Some methods might not require any parameters. It will create a new request ID using a random UID. And then like if it has parameters or not, it will prepare the JSON correctly. It will serialize the request. So yeah, this object that we've prepared, it will convert it to JSON. And then it will create this task completion source that it will append to the dictionary. And it will write the request in the standard input of the SDK's process, and then it will wait for the task to be completed, which, as we saw before, will happen here whenever there's a result that we collected. Let's go back to documentation once again. So right now, we have the setup done to start implementing specific methods to the SDK. And so the last section here is about error responses. So this was basically what we were seeing in the code. Basically this branch here. So if you don't even have a result field in the JSON response, then something went wrong and the SDK was not able to call the method that you wanted. And there are three reasons for that. One is that the JSON is malformed, or we couldn't parse it. In that case, the code will be -1. The second case is about invalid state. So if you are trying to call a method that requires setup to be called, which we'll look into the next section, and you haven't called setup, or it was not successfully finished, then we could not call your wanted method, and we'll return this code. And the third possibility is if there's some illegal argument exception. So for example, I don't know, if method expects a positive integer and you're sending a negative integer, for example.